So this is week 10. So we are going to do tutorial sheet 10. I assume you know which is tutorial sheet 10. Um, so let me change the camera right now. Um, okay, here we are. I hope you can see this. This is the tutorial sheet number 10. It has 5 questions, as you can see. It has 5 questions. So I will start with question 5 and work backwards. Um, and if you have questions, as usual, please use the chat room, right? And I'm happy to answer any questions you guys have in detail, as much detail as possible. Okay, guys. So let's start with question number 5. Question 5 is okay. You have, if you can't read this, guys, please go to the course website, and you'll be able to read it much better in the course website. Okay, all right. It says there are 288 voters in California, and out of that, 141 voted in the presidential election. And it also says that there are 216 voters in Colorado, and out of that, 125 voted in the presidential election. And the question is to find a 95% confidence interval for the difference in the proportion of people voting in California and Colorado, right? Okay, now let me show you. Last week, if you may recall, we talked about 4 different confidence intervals, right? And these are the four different confidence intervals we talked about last week. This is the confidence interval for the difference in population means when the variances are known. And this is the one for the difference in population means when the variances are unknown but equal. And this is the one for the difference in population means when the variances are unknown, and not equal. And finally, this is the one for the difference in population proportions. Now, of these 4 different confidence intervals, which one you think we should apply for question 5? Hello, guys. I mean, clearly, question 5 is talking about proportion. Of these 4, the one that is talking about proportions is the last one. So we need to use this formula to do question number 5. Okay, so that's what I'm going to do now. Um, so let's start with question 5. Okay, so the formula. Let me write down the formula one more time. Okay, this is the formula that we're going to use to answer this question, because this is the only formula that talks about proportions, right? Of the 4 formulas that I gave you last week. All right, now x bar is the sample proportion for the first population. Now, if you go back to the question, if you return to the question, it says that 141 out of the 288 voted in California. So the sample proportion for the first population is 141 divided by 288. And y bar is the sample proportion for the second population, which says that 125 out of 216 voted in Colorado, right? So this is going to be 125 divided by 216. Okay, and M is the sample size for the first population, and N is 216. And we are looking for 95% confidence interval, which means that 100 times 1 minus alpha is 95. All right, and this implies that alpha is 0.05, right? So, your z 1 minus alpha by 2 is this, and this is equal to 1.96. You should read this off the table for the normal. The table for the normal distribution is on the course website. You should go to the course website and look at the link. There's a link called formulas, right? If you look at that link, it gives you the table for reading this, right? All right, now what I'm going to do is I'm going to sub all this data into this formula here so that you will get the following. You will get uh, I think the camera is playing around again. Sorry guys, I've got problem again with the camera, so let me adjust it. Okay. Mm. Can you see my writing? Okay, let me know if you can't. It, if you cannot see my writing, please let me know. Okay. Sometimes I get into problems with the camera or the computer. I mean. Okay. Right. So this is the formula that you will get after applying all these numbers into this. Right. So if you simplify this, the lower limit will be this, and the upper limit will be this, right? Okay, so basically, this is the 95% confidence interval for the difference in proportions in voting between California and Colorado. So since this interval is on the negative real line, what it means is that the proportion in California is smaller or significantly smaller than the proportion of people voting in Colorado, all right, because of the negative interval, all right? Is this clear to you guys? Any questions, guys? Are you sure? Okay, thank you. All right. So let me go. So I'm done with question 5. The next question I'm going to do is question 4. It's this one, right? So here you have two brands, A and B, brand A and brand B, and we are trying to compare the mean absorption times. And you're given the numbers and the sample mean and the sample standard deviation. The question is to find the 95% confidence interval for the difference in the means, assuming, it says the crucial part is here, assuming that the times are normally distributed with a common and unknown value for sigma squared. So this is the most crucial part of the question is this one here. So it assumes that the absorption times are normally distributed with a common and unknown value for sigma squared. Sigma squared is the population variance. Right, now returning to the formula sheet, which one do you think we should use? I mean, it has to be one of these three, either this one, or this one. Which one should we use and why? Hello guys, talk to me. Remember, this is the formula to use when the variances are known. This is the formula to use when the variances are unknown but equal. And this is the formula to use when the variances are unknown and not equal. So in this question here, in this question, we are assuming that the variances are common and unknown. So that means we need to use the second one. You're right, Cameron. Thank you. So we're going to use the second formula here, right? Okay, so let's see how we can do it. Excuse me. So this is question number 4. So let me write down the formula first. Okay, so the formula I'm going to use is x bar minus y bar plus or minus okay, this is the formula I'm going to use. Okay. Okay, now I'm going to write down everything that is given to us. X bar is the sample mean for brand A, which is given to us as 21.8. Y bar is the sample mean for brand B, which is 18.9. Right, M is the sample size for brand A, and N is the sample size for brand B. Right, okay, so these are, okay, the next thing we need to do is we need to compute this guy here. This guy is known as this pooled sample standard deviation, right? You may recall earlier. And the formula, you should recall from what we did last week, the formula for the pooled sample variance is the following. This is the formula you should recall from what we did last week, guys. All right, so I'm gonna sub in the numbers. M minus 1 is 11, right? Because M is 12. Sx squared is the sample variance for the first brand A, which is 8.7 squared. Sy squared is the sample variance for the second brand, divided by m plus n minus 2 is going to be 1122. Okay. Now, if you work this out using a calculator, this is what you will get. Okay. So we got everything except this one. This guy here, now we are looking for 95% confidence interval, right? Which means 100 times 1 minus alpha is 95, right? Which implies that alpha is 0.05, okay? So T, this guy here is gonna be T with 22 degree of freedom and 0.975. Now, if you look this up in the table, which is on the course website, you will get 2.074. Okay, guys. Now, actually, if you go to the table, there is no 22 in the table. So you need to look that is the closest to 22, which is either 20 or 24. So you will get something close to this. You should do that. Okay. I mean, as I said before, all the tables are on the course website. You should go to the link. There is a link called formulas on the course website. And you should click on that link and go to the very bottom of that link. You will see all the tables, right? Okay. Right, now I've got all the data, so I'm going to sub it into this formula here, into this formula. So X bar is 21.8 minus 18.9 plus or minus 2.074. SP is the square root of this. M is 12, N is 12 too. All right, so this is the 95% confidence interval. Now, if you simplify this, the lower limit will be this, and the upper limit will be this. So this is the 95% confidence interval. So what this means is that because this is from a negative number to a positive number, it contains the value 0. I mean, this interval clearly contains the value 0. So hence the what you can conclude from this interval is that the mean absorption times for brands A and B are not significantly different. That's because of the fact that it contains the value 0, right? So the mean absorption times are not significantly different from each other. That's what you can conclude from this. Right. All right, guys, are you okay with this or not? Anything you want to ask me about question 4? Please let me know. Hello, guys, talk to me. Are you okay with question? Any questions? Okay, thank you, Cameron. Anybody else? Anybody else who has questions? All right, so we're done with question 4. Now the next question I'm going to do is question 3. Question 3, you have around 2 random samples from a population with mean, mu, and variance sigma squared, and you have the sample means and the sample variances, and you have these 2 different estimators. This is the estimator for mu. This is the estimator for sigma squared, right? And there are 2 questions. The first part is to show that the 2 estimators are unbiased. All right, let's try to do that first. Okay. I'm sure you guys know how to show something is unbiased, right? I mean, I did many examples on bias earlier on in the course, you may recall. Uh, right, so this is question 3, part 1. Let's go back to the question. So the estimator for mu is n x bar plus m y bar divided by n plus m. All right. And we want to show that this estimator is unbiased. So what you need to, you probably remember this, to show that something is unbiased, you need to show that the bias of it is 0, right? Okay. All right, so this becomes this. Now, if you take the expectation inside, guys, anything not clear, please feel free to shout at me, all right, if anything not clear, okay? If you take the expectation inside, this is what you will get. Okay. All right. Now, in the next line, in place of x bar, I'm gonna put the definition, which is, I'm sure you know, this is the definition of x bar. And in place of y bar, I'm gonna put the definition of y bar, which is okay. All right, in the next step, I'm going to take the expectation inside the brackets. So this will be 1 divided by n plus m. Okay, this is what you get. And you see the n and the n cancel out, the m and the m cancel out, right? So what you have is the sum. Now we know we are told that the population mean is mu, so this guy is mu plus this is also mu. Okay. Now this becomes the sum of a constant is n times mu. The sum of a constant, this is also this is m times mu. Right? And this is clearly equal to 0. So hence we have shown that the bias of the estimator for mu is equal to 0. So which implies, guys, that mu hat is unbiased for mu. All right? Is that clear, guys? I mean, is this clear to you guys or not? Okay, thank you. Thank you, Robert. All right, the next thing I need to show is the same thing for the next thing I need to show is the same thing for the estimator for sigma squared. Now the estimator for sigma squared is given here. So this is still question 3, part 1. The estimator for sigma squared is given as follows. Okay, this is the estimator for sigma squared. Right, so once again, I want to show that the bias of this estimator is 0, right? So let's see how we can do this, right? Oh, the computer is playing again. Just a minute, guys. Just a minute. Just a minute. I've got problems with the computer again. Oh shit. Come on. What's happening? Oh. Just give me a sec, guys. Just hang on there. Okay. Okay, I think it's okay now. All right, so this is the expectation of n minus 1. This is what you get, right? Now you should take the expectation inside. This is what you will see. All right, this is what you will see. Right now, in the next step, I'm going to use something that I proved much earlier on in the course. You may recall, I think I did this in week 2 or week 3 of this course, that the expectation of a sample variance, which is this, is equal to the population variance. I mean, if you don't remember this, please have a look at what is the stuff I covered in week 2 or week 3 of the course, right? Okay, and similarly, the expectation of this guy here is also sigma squared. So this becomes okay, and these two guys cancel out. So the answer is 0, right? So hence I have shown that the estimator for sigma squared is unbiased for sigma squared, right? Is that okay, guys, with you? Hello, guys. Is this okay with you guys or no? Hmm? Thank you, guys. Thank you. All right. So the next part I'm gonna do. So I'm done with part 1 of question 3. Okay. The next part. So the next part we are asked to do is to obtain an expression for the variance of mu hat and say what happens when n goes to infinity and m goes to infinity. So let's see how we can do this. So this is part 2. So this is question 3, part 2. So we are asked to find an expression for the variance of mu hat. Now mu hat, as we saw earlier, excuse me, the mu hat is equal to the variance of n x bar plus m y bar divided by n plus m. Okay, excuse me, still playing around, don't know why. All right, this is, so we need to find the variance of this. Now these are, n is a constant, n plus m is a constant, m is a constant. So you should take the variance inside. This is what you will get. Okay, you follow me? Because you need to square, like when you pull out a constant outside, you need to square it. I'm sure you know that. Okay, so this becomes, okay. So you see I have replaced x bar by the definition and similarly for y bar. Okay, now I'm gonna take the variance inside the brackets. So this is gonna be so if you take it inside, you need to square the n like this, right? Like this, okay? Now these two guys cancel, and so are these two, right? So you get 1 over n plus m squared in brackets, sum 1 to n. Now variance of xi is given in the question as sigma squared. And similarly, the variance of yi is given as sigma squared, right? Okay, so this becomes the sum of a sigma squared is sigma squared is a constant, so sum of it is n times sigma squared, and similarly this is m times sigma squared. All right, and this, you simplify, this becomes this, right? Okay, guys, and this clearly approaches zero as n goes to infinity or m goes to infinity, right? All right, so are you guys okay with this? Or any questions, please let me know, guys. I'm happy to answer anything you have, any questions you have. Hello, guys. Are you okay? What? Hmm? Hello. Any questions on this, guys? Are you okay? Okay, thank you. All right. So we're done with question number 3. So the next question I'm going to do is question 2, which is this one. So here you have 2 different brands again, and there are 150 light bulbs from brand A, and they have a mean lifetime of 1,386 hours and a standard deviation of this. And you have 200 light bulbs from brand B, and their mean lifetime is this, and the standard deviation is this. The question is to find a 95% confidence interval for the difference in mean lifetimes, assuming this or this. All right. Okay, so here, this question is again about the difference in means, difference in population means, okay, corresponding to 2 different brands, right? Okay, now let's take the first part where we need to assume that the variances are not equal, or the population variances are not equal. Now, let me ask you, there are three formulas, okay, on difference for confidence intervals for differences in population means. Which one do you think we should use for the first part? Okay, this is the one when the variances are known. This is the one we should use when the variances are unknown but equal. And this is the one we need to use when the variances are unknown and not equal. Cameron says first one. Lan Su says first one. What do you think is the first one? Why? I mean, for the first formula, guys, for the first formula, the variance, you need to assume that the population variances are known, right? But the question does not say that, though. If you look here, guys, does the question say that the population variances are known? I don't think it does. I mean, hello, guys. I mean, if you read the question one more time, the question does not say whether the population variances are known or not. I don't think it does say that. So which one should we use? We should use the number 3, which is, we should use number 3 because this is the formula for the confidence interval when the variances are unknown, the population variances are unknown and not equal, right? And that's what we are looking for here in part 1, okay? So it's really important that you get the formula correct, because if you choose the wrong formula, then you get 0 credit for you know what I'm saying? You don't get any mark if you choose the wrong formula, right? Okay. All right. So let's see how we can do this. So okay, let me write down the formula first. So the formula is this. This is the formula that I'm going to use, okay? Let me put this in the box, okay? All right, now let me write down what is given to us. We are told that x bar is the sample mean for the first brand is 1386. Okay, we are told that y bar is 1218. M is the number, the sample size for the first brand, which is 150. N is 200. And we are told that the Sx is the sample standard deviation for the first sample, which is 114. Oh, sorry, it's giving me trouble again, the computer. Oh, man. Okay, so this is 114, and Sy is the sample standard deviation for the second, which is 98. So we are given all this data, right? Now, I'm going to apply a trick here. Remember, I'm going to remember one of the properties I mentioned on the video on student t distribution is that if the degree of freedom is large, then you can approximate this by the standard normal, right? And the sample sizes that we are looking at here are pretty large numbers. So you have a sample size of 150 and a sample size of 200, which are very large. Because in statistics, anything above 25 is considered a large sample size. So certainly 150 and 200 are very large numbers in, in statistics. So you can use the approximation. You can use the approximation that this guy here can be approximated by this. Right, let me just adjust the computer one more time. Um, Sorry guys, I don't know why. Okay. Right, okay, you see what I have done. The reason for this approximation is you can all right, okay. So you're allowed to you're allowed to make this approximation because of the large sample sizes, 150 and 200, right? Okay. So come on, what's happening? Okay. All right. So I'm going to use this formula here to answer the question. All right. So if you use this formula, x bar will become 138. Sorry, 1386. I mean 1386. Right. Y bar is 1218. plus or minus. This guy we know is we are looking for is 1.96 because we are looking for 95% confidence intervals. Oh, come on, this is giving me issues. Sorry, just bear with me, guys. I got problem with the computer one more time. Sorry, guys. Just be patient with me, all right? I've got problems. அம்மா அம்மா மேல வாரி பிரச்சனை அம்மா கம்ப்யூட்டர் பிரச்சனை பட்டுதான் செய்யறேன் இங்க stop not responding
Zoom
Zoom not responding
அவன் க்ளோஸ் பண்ணி போடுங்க
அவங்க